Hopefully by now you've had a chance to get some ideas and brainstorm how you might prime factor when you have variables involved. So the first thing I want to do is I want to focus on this 24. I know that this ends up coming out to 6 and 4, which breaks down into 2, 3, 2, and 2. Now the thing about variables, we don't know what they represent, so therefore they are prime. So if I work over to the side here, I know that x squared is simply x times x. And I know y is all by itself already. And z to the 5th, well, I know that's 5 z's. So while technically you could write those in exponential form, it's nicer if you don't, because then it shows you understand how to break them up. So I'm going to write down that my prime factorization is 2 to the 3rd times 3 times x times x times y times z times z times z times z times z. I know that's a mouthful, but that's the way we're going to have to do it to make sure you're demonstrating that you understand what's going on. Now the last one here, 51 a to the 3rd b to the 3rd. 51, a lot of people want to say it's prime, but if you look at it, 5 plus 1 is 6. That's divisible by 3, so I know this is divisible by 3. And if I take a 3, 3 goes into 5 once. With 2 left over, 3 goes into 21 7 times, so it's actually 3 times 17, both of which are prime. A cubed, so that is a times a times a. So and b cubed is b times b times b. So my prime factorization is 3 times 17 times a times a times a times b times b times b. Then if you want to go ahead and highlight that, it might make your life easier so you can see where it is. Your job now is to go ahead and use the method of your choice. I don't care whether you use factor trees or whether you use the ladder method. Notice I used a little bit of both. And go ahead and factor these 3 problems and bring them with you along with your questions to class tomorrow.